The vector OX and OY are position vectors relative to the origin O. Given the points X, so X is 3, -5, and Y is -2 and 7, write OX, write the vector OX and OY as column vectors. And so in order to write the vector OX as a column vector, we're just going to take the coordinate of X and we're going to, instead of writing it horizontally, we're going to write it vertically. And so that means that OX, the vector OX is equal to 3, put the 3 on top, put the -5 at the bottom. So we take the coordinates of X and we just write it, instead of writing it horizontally, we write it vertically. And so we have 3 on top and -5 at the bottom. We do the same thing for OY. So vector OY written as a column vector, we just take the coordinates of the point Y, and instead of writing it horizontally, we write it vertically, right? And so we put the -2 on top, we put the 7 at the bottom. And so these are the column vectors of OX. So these are the column vectors OX and OY. Okay, now the next question states, express XY as a column vector. So, all right, so what is XY? Well, XY is going to be equal to XO plus OY. Now, why is that the case? So you could think about it like this. So you can say, okay, well, imagine that we have the point X here. So imagine this is the point X. And O is the origin. And imagine that the point Y is here, okay? So, and this is the origin. So we're trying to get from X to Y. So we're gonna go from X to O, all right? And then we're gonna go from O to Y. And that's what we did. So we go from X to O. That's what we have here, X to O. And then we're gonna go from O to Y. So O to Y is here. And so that's the way that you can think about it. And so, okay, so what do we have, right? What do we know? Well, we know, based on our previous question, we know what OY is, right? We know explicitly what OY is. OY is -2 and 7. But the problem is we don't know what XO is, right? We don't know what XO is. Now, what we do know is we know what OX is, but we don't know what XO is. So we're gonna do, but what we notice is that OX is just XO, but we just switch the letters. So in order for us, we don't know what XO is, but we know what OX is. So what we're just gonna do is we're just gonna switch the letters. And if we switch the letters, then we could be able to use this column vector, right? So let's switch the letters. So instead of writing XO, we're gonna write OX. And the reason for that is because we know what OX is. We don't know what XO is, but we know what OX is. So we say, okay, let's just switch the letters. Now, there's a penalty, however, for switching the letters. We can switch the letters, that's fine. But there's a penalty for switching the letters. And the penalty for switching the letters is we have to put a negative sign out front. So in order for these two to be equal. So XO is equal to OX, but you need to put the negative sign here. And so we good. So we have that XY is equal to -OX plus OY. And so we could substitute, right? So we can say that OX is equal to 3 and -5, and OY is equal to -2 and 7. But do not forget your negative sign out front. And so we have -1 multiplied by 3, which gives us -3. And we have a -1 multiplied by -5, which gives us +5. And so we have -3 and 5, and then we have -2 and 7. And so this is what XY is. Now the next step we're gonna do is we're going to add these factors. So we have -3 plus -2, and -3 plus -2 is -5. And we have 5 plus 7, and 5 plus 7 is 12. So XY is equal to -5 and 12. That's what the vector XY is equal to. All right, so now that we know what XY is as a column vector, let's figure out the magnitude of XY. Now, in general, if we're trying to figure out the magnitude of a vector, we're gonna take the first coordinate and square it. We're gonna take the second coordinate or component. We're gonna take the first component and square it. We're gonna take the second component and square it. And we're gonna add those two, and then we're gonna take that sum and take the square root of it. So that's basically how we calculate the magnitude of any column vector that has two components, right? So in this case, to figure out what is xy, we take the first component, we square it. So we take the first component and we square it. So we have -5 squared, right? We take the first component, we square it. We take the second component, 12, and we square it. So 12 squared. Then we have to add them, and then we're going to take the square root of it. So -5 squared is simply 25, and 12 squared is 144. Next, we add the two. So we have 25 plus 144, and 25 plus 144 is 169. And so we have to take the square root of 169, and the square root of 169 is definitely 13. So that means that the magnitude of xy is equal to 13. And that's the answer to this question.